In the previous session, we have seen dynamic array. In this session, we will see the queues in SystemVerilog. Queue we have queues, right? So we will see the queue. So a queue is a variable size unpacked array. Now the dynamic array was also unpacked array. Queue is also a unpacked array, but it is variable size. In unpacked array, in which element can be added or in which, so how we can read the definition in good manner, that is, a queue is a variable sized unpacked array. Okay, so here we need to put a comma. Then in which element can be added or removed during simulation. During the simulation means during the runtime. Okay, simulation means what? Simulation means runtime. So during the runtime you can add the element and you can remove the element. The biggest advantage of queue is that its size can be grow or shrink automatically. Now in a dynamic array we are allocating size. We are the one who is allocating the size, how much size we want at the runtime. Now in the queue we don't need to allocate the size. Queue automatically shrink or grow based on requirement. Okay, so for example int queue. So how you will declare the queue? So this is how you will declare the queue. This is the type of queue. What is the type? Int type of queue. If you use byte means byte type of queue. So you can use any data type here. Then this is a queue name. So this will be the queue name and this will be the dollar. See, in a dynamic array this was empty. During the declaration we are not doing anything. But here during the declaration only you need to put dollar sign. So dollar sign indicates it's a queue. Index start from, in this case index start from 0 and it will go till size -1 or maximum, you can say okay, size -1 only, no problem. Or else you can remove that. We will see how we are doing. The index will start from 0, that is for sure. Later we will see how the maximum size it will come. It means, like, suppose you put 5 elements, so the size will be 5 minus 1, that will be 4. So it will start from 0. So here what are the things you should know in this case? Int is a type of each element. Queue is a queue name and this is a queue. This is a queue representation. So you have to use a square bracket. Inside that you have to use dollar symbol. So basic example, you see, we declare queue. Inside the module we declare int queue and dollar symbol. Now inside the initial begin, and here we are initializing the queue. So see, before we are directly initializing using index, but here what we are doing, we are using some methods. So add element to the queue. So here we are using some methods, that is pushback. So this is a queue method. It's a already inbuilt method in SystemVerilog language. This is used by the queue. So here what we are using, pushback. So from the back side of queue, what element we are pushing? 10. Again what we are pushing? 20. Again what we are pushing? 30. So but here we didn't declare a size, right? We didn't allocate memory, but we are pushing the element. So till this point, how many elements we pushed? Total we pushed 3 elements. So the size of the queue will become 3. Here we are displaying. So the output will come like this. Okay. Why? Because this is called as packed format display format specifier. So here we are displaying the array in packed format. So you will get the result in this format. So if you remember, this is what format we are used to initialize also sometimes. That is called array assignment pattern. So you can print also. How you will print? Without using for each loop. See, here we are not using for each loop. Still we are able to print all these 3 elements because of this %p. Okay. So how you can visualize the queue? So you can visualize in this manner, queue, and here total what are the size? 3 size. So queue, then at a 0th index it will come 10, and 20 will come on a first index, and 30 will come on second index. Okay, I hope you understand. Let's move to see the next thing, that is, why do we need queue? So that will be the question, right? We already studied so many types of array till now. What are the types? packed array, unpacked array, static array, dynamic array. Then why do you need queue? So suppose you are verifying a duty design and transaction arrive one by one. So in that duty transaction arrives one by one, but you don't know how many transaction will come. The final result you don't know. So suppose transaction is coming like 1, 2, 3, 4 dot dot dot. So you don't know in advance how many transaction will arrive. In this case, what you can do? You have so few options. What are the options? If you use static array means you can directly declare 100 elements array, 100 size array. In this case, the size is fixed. See, in this case, size is fixed. If you use dynamic array, then the transaction you will declare like this, and it can be resized, but we have to manage the allocations. Like this is fine. We can resize it whenever we want, but we have to manually give the size. We have to allocate the size. This is the main point. But in queue, if you use queue means you have to declare like this, but you don't need to manage manually. Automatically it will grow and sync as you add or remove the transaction. So in this case, suppose 50 transaction is about to come. In this case, 50 size is wastage, right? In this case, suppose one transaction, 10 transaction come first, or you allocate size 10 first. Then again you are reallocating. So you have to manage the allocation. But in this case, what will happen? 50 transaction is coming, na? No problem. It will add one by one. Total 50 transactions it will add. Here you don't need to do manually things. Here memory wastage will come. So 50 memory will be wastage, 50 memory you will be using 50. So this is what the why we need queue. This is how it is solving a problem, real time problem. So this makes queue very useful in verification, especially for storing expected transaction, pending request, scoreboard. Okay, all those places we will be using this queue. So now see what are the types of queue. So we will see the types of queue. So there are mainly two types of queue based on how their size is restricted. So based on a size, they categorize queue into two part. First is unbounded queue and second is bounded queue. Name only telling what is the meaning of unbounded and bounded. Unbounded means size is not fixed. Bounded means size is fixed. Okay. So bounded means size is fixed. Unbounded means size is not fixed. So for the unbounded queue, the syntax will look like this. Syntax is equals to data type of queue name, and inside the square bracket you are just passing dollar symbol. So there is no specific maximum size. Here there is no size, right? You didn't mention a specific size. It will go to infinite. So it can grow as needed. So whatever you want, how much you want, it will grow that much. Like suppose you want 20, you are pushing 20 element, so it will grow to till 20. Again you are pushing 50 element, then it will grow to till 50. Okay, so this will look like this. So this is an example. You are pushing 10 elements, 20, like you are pushing value 10, 20, 30, 40. So it will be look like this. But second we have bounded queue. So in bounded queue the size is fixed. Okay, so the syntax is data type, queue name, and dollar. So this dollar will indicate it start from 0 and it will go to maximum index. Maximum index, it can be 9, 10, something, anything. So in this case you see, this is an example. So in this case you can see how it is growing, how it grow, how it shrink. So in this case it will grow. So see, int is a queue type, this queue is a queue name, and it start from 0, it will go to till 3. That is fixed. So in this case size is fixed, na? That is why it is bounded queue. The queue can contain at most the maximum how much element it can contain, 4, because the maximum number of index is 3. Okay, it means it can contain one element also. It can contain 2, it can contain 3, it can contain 4. The maximum it can contain 4. If you give 5 means it will throw error. Okay, so this is how index will start from 0, 1, 2, 3. See, this is the MSB part. So this is 0 and this is the LSB part. So it will come here, and total how many elements? 4 elements. So this is the maximum index, correct? So at 0th index we push 10, first index we push 20, second index we push 30, third index we pushed 40, then the maximum index will be third. Okay, so this is in code. You can see everything is same, whatever I explained you. You can just type this code and run. Apart from that, if you try to add another element, so see in this case what is the size total? 4 only. If you want to add another element na, it can't grow beyond that. So that is the maximum limit. The queue cannot grow beyond its declared maximum capacity. The exact behavior depends on operation context for achieving the simple okay. So this is what you need to remember. In a bonded queue has a maximum number of elements. Unbounded queue does not. Bonded queue, it won't grow beyond the maximum index. But unbounded queue can grow to till infinite. Okay guys, so I hope you got this concept of queue in SystemVerilog. If you understood, if you understand, then like my video and subscribe my channel for the further updates. Bye guys.